Right. So let's get started. This workshop will be about matrix, a little bit of kind of the scalar multiplication stuff, but mainly matrix multiplication. I have a collection of problems about that. It's really not that many. It shouldn't be too hard or take too long to get through. So if we do have extra time, then we can talk about other midterm questions or whatever you want to talk about. But we'll see how long it takes us to get through these ones first. So we did matrix addition stuff, addition, subtraction, transposing in the previous workshop. So this workshop kind of some of the harder operations. All right, so first one is scalar multiplication. These ones are pretty simple, but let's just make sure we all remember how to do this. So take a moment, go ahead and try to write out what all these are. Okay, so let's just go through these ones quickly here. I will just choose some random people. So 13, we are doing 3 times matrix B. Okay, Huilin, can you start? Can you tell us 3B? First, each row in order. Mm-hmm. 192. Everyone agrees? Okay, good. So first one, we have also -4 times matrix C. Can you tell me? Sorry, I'm just gonna close the door so I can hear you better.
Sorry, I had an appointment with the professor.
That's all right, that's all right. Okay, can we try that again? Okay. 12. 28. 72. Okay. 360. 116. Do we agree? No? Why not? So, on which one? All of them. Okay, so if we have a -4 here, the negative, it's -4 times each thing. So negative, 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 negative on all of them. All right, last one was 100 times D. Volunteer? Who wants to tell me what this one is? Okay, Clemens, go ahead.
1,800.
Okay.
1,200.
Who has the, is there someone listening to the workshop on their computer? I felt like I heard an echo from your voice. No? Okay, if someone is, just make sure you mute your speakers, otherwise we hear those echoes. Okay, keep going.
So 1,300.
Mm-hmm.
800,
Mhm.
1,400, 600, 700, 400, 2,100.
2,000. Okay, so just the outside number times all of the inside numbers. That's all that has to happen. So very, very simple operation to do. Come in, come in. Hello. That's all right. Any questions about scalar multiplication? No. All right, so I'll erase. No good. Okay, so first matrix multiplication ones are these. You have these four matrices and these three operations. Remember to check first if they are possible. So don't start writing out all the numbers and start doing calculations because they might not actually be possible and then you're just wasting your time. So check first if they are actually possible. Go ahead. Okay, let's take a look at our answers for these first three here. So most people are finished, I saw. How many people have the same answers as like their partner or the people sitting beside them? Some. Same answers, you two? No? You guys can't agree on. Okay. So first one, BC, is this possible or not? Possible. Okay, so what are the dimensions of matrix B? 2 by 3. Okay, 2 rows, 3 columns. And C? 3 by 2. Okay, so matrix BC should have what dimensions? 2 by 2. 2 by 2 matrix here. Okay, let's see our results, and then if we have disagreements about our result, we can actually do the calculation here. All right, so I'm gonna pick some people again. Can we try again, Elena? You finished this one, so you can tell me your numbers. 20? 132? 28? 20. Do we agree? No, okay. Who else wants to tell me their answers? Clements, okay.
20, 102.
102. 28. 28. A lot of people got this result? Yeah. Okay. All right, so let's talk about how we do this. Let's do some different colors here. So lots of ways you can organize it the way I was showing you in class. We kind of write the first one, it's not big enough, sort of on the left here, 3, 6, 4, -8, 0, 12, and write the second one, which is C, sort of above here. Try to write straight lines a little better. 4, 10, -2, 6, 5, and 9. All right, so this one's a little bigger, so it's probably useful to kind of, write some, maybe this plus this plus this, and then add it afterward, just so we don't make mistakes. So I'll just give myself a bit of space for that. So let's say the first position here, what are the three numbers? What plus what plus what? 12 minus 12 plus 20, okay? For our, let's move this over a bit more. For our second position, what do we have? 30 plus 36 plus 36 again. Okay, so we see 12 minus 12, 20. There's our 20. We see 36, 30, 36, 36, 72 plus 30, 102. That's this, okay? For our third position here, what do we have? Yeah, plus 0, plus 60. Okay, so 60 minus 32, that gives it 28 here. And our last one, negative 80 plus 0 plus 108 here. Okay, so 108 minus 80 is 28. So Elena, the numbers you gave us, the first column was correct. So you might have just copied down the wrong number for one of these, and that gave you just the second column wrong. So you can check recheck these matrices, make sure you got this second column, that you had the right numbers on your page there. But you got the first numbers right, so your process was probably correct. Okay, and then yes, if we add these together, we get this second result here. So just so we all remember, each position here, like this first position, is just this row times this column, and inside that it's 3 times 4 plus 6 times negative 2 plus 4 times 5, like this. And same thing for all of them. Questions about the process? No? Okay, so let's look at the next one. Our second was B times D. Is that possible? Yes, okay. So B, I just had B, I shouldn't have erased it. B times D. Can someone give me who wants to give me the result here? Okay, G, go ahead. So 60, 41, sorry, 2, okay. Negative 16, 120, negative 216, okay. That's it? So 2 by 3 matrix? Okay. So that and that. All right, so B times D. So B is a 2 by 3 matrix. D is a 3 by 3 matrix. Inside number is 3, possible outside numbers 2 and 3. So that gives us our size here, 2 by 3 matrix. Does anyone disagree with the result? Disagree? Okay, so we're all fine on that. All right, and different color here. Our last one, C times B. So C is a 3 by 2 matrix. B is a 2 by 3 matrix. So what size will our result be? Okay, so 3 by 3 matrix. And who can tell me this result? Okay, negative 68, 24, 136, negative 54, negative 12, 64, negative 57, 30, 128. Do we agree with these numbers? Okay. So All right, if everyone agrees, I'll trust that we have it correct. I don't like memorize the answers in advance or anything. But yeah, size is right, numbers look approximately correct. Anyone have questions, concerns on these ones? Okay. When I saw, looking at a bunch of you writing your notes, a lot of you, when you were kind of writing out what the results are, like you had this intermediate step of like, this thing times this thing plus this thing times this thing plus da, da, da. It's probably faster if you just write kind of the result of the multiplication. This plus this plus this. Like any parts that you can do in your head quickly, just combine those, do those, and then that's just less writing, you'll be able to work faster. Like you don't need to write out exactly every single part of it separately. Okay, one more set of these here. So you might notice something different. These ones, squared. What do you think squared is for a matrix? B times B. That's it. Okay, go ahead. Everyone fine? Didn't you? Okay, so most people here in the classroom are finished. I hope that means most people online are finished as well. All right, I asked classroom people for the last one. So how about this time we go with the online people? Anyone? Is there someone online who would like to give us their answer for 31? Okay, so first tell us that
It's possible.
So it sounds like your microphone is like rubbing against something.
How about now?
Still rubbing a bit against something. Try again.
Can you hear me well?
Okay, this is better, yeah.
Okay, the B times A is possible.
Okay, so possible, and what size will the result be?
2 by 2.
2 by 2 matrix, all right. And tell me the first row.
Minus 350.
Negative 350.
And 1050.
1050.
And the second row, 300 and 350.
300, 350. Thank you. Okay, do we agree with the numbers? Yes? No? Yes? No? Second row, 350, 350. Okay, so in class we're hearing second row should be 350, 350. Now do we agree? Yes? Yes? Maybe? Yes? Yes? Okay. All right. Okay, so great. I think we have this one then, if everyone agrees on this. I'll do 33, and some of these other ones I'll do in a bit of detail just so we can notice some patterns with this one, with them. But this one is just a 2 by 2 system, or 2 by 2, two 2 by 2 matrices, nothing especially complex there. Okay, Next one, so 33. Is this one possible? Yes, okay. So they're both 2 by 2 matrices, so we just have B, which is our 40, 10, -20, and 30. And B again, 40, 10, -20, 30. Maybe move this over a bit. I'll move this up a bit as well. All right, so first position here, what do we have? What plus what? 1,600 minus 200. Okay, next position. 400 plus 300. And next one. Negative 800. 600, okay, and negative 200 plus let's do that. Plus 900. Okay, and then if we add these things up, we will get, we can just do these easily, 1,400 and 700 and negative 1,400 and negative 700. Or sorry, yes, here, positive 700. Okay, so we might kind of look at this and see, well, maybe there's some kind of pattern going on here. What do you think? Is it a pattern or is it just kind of a random chance that happened? Yeah, so if there was a pattern, then the signs would kind of have to match on these, but they don't. Also, inside here, if we look at these, the things that we were adding or multiplying together to get each of these, they're completely different. They just, in this case, they happen to be similar. So with kind of squaring just sort of regular numbers, often there are patterns and stuff we can notice, but when you're squaring matrices, you just, like there's no kind of shortcut to it. You just have to still do the whole matrix multiplication for it. So no real kind of fast or easier ways to do it. We just still have to do the whole thing. All right, so that then is, I should just label that here. That is our B squared, this matrix. All right, that was that one. What about our next one, C squared? Impossible, we say. Right, let's get this. So C is a 3 by 2 matrix, and C, again, 3 by 2 matrix. So inside numbers are not matching, so that won't work. What versions of a matrix times itself would always work? So obviously, if we have some generic matrix, let's use a different letter, like H squared, it's not always possible. It's only possible actually if it is a square matrix, if the rows and columns are the same. Otherwise, it won't work. But are there other ways where it will always be possible, one matrix times itself, but with maybe some changes? So like H times H, this is a maybe. Sometimes it works and sometimes it doesn't. For just any matrix H. Can we think of other things that might always be possible with just two copies of the same matrix? The identity matrix, that will always work. How about just for a generic any matrix H with maybe some small changes made? Transpose. Okay, so tell me what could work. So H times H transpose will always work, and then the same way around, H transpose H will also always work, because so if H has dimensions A by B, then H transpose must have dimensions B by A. If we do H times H transpose and H transpose times H, will we get the same results or different? Different. We can even see if we were to look at these things here, we'd get completely different sizes even. So not just the same different numbers, but different dimensions as well. Okay, so H squared, or for any matrix H, or squaring a matrix doesn't always work. If you multiply it by a transpose of itself, that will, but not squaring. All right, let's do our last one here. Screen again. So B transpose and C transpose. This one, we can kind of see some shortcut stuff that we could use. So that's what I want to show you. Let's do this. So B transpose. What is B transpose? 40, negative 20, 10, and 30. Okay, so remember, a transpose is a diagonal flip. It is not a rotation. The values in the main diagonal need to stay the same. If any of those change, you've done the transpose wrong. If we rotate, all of those will change. Okay, and our other one, we said C transpose, which is -1, or you tell me, what is C transpose? -1, 0, 1, 0, 1, and 0 here. Okay. Did anyone notice like shortcuts or notice kind of patterns inside the solution? Okay, let's write out the result and then we can talk about what those are. So what is our first row here? -40. Sorry, louder. 20 and 40. -10, -30, and 10. Okay, I'm gonna change the question a bit. And we'll do one more column here to help you see. So 0, 1. Let's pretend I add this. What would I have for my last column here? -20, 30. Is anyone seeing anything here? What do you see? It's just hard to describe. Okay, so let's pretend we have kind of two separate parts like this. Does that help you see it? Yeah. How do they relate to the starting matrices? You're halfway there. Edom, you have your hand up. You have an idea?
The negative of the matrix.
Of which
the
one?
First matrix of
Okay.
B transpose.
So this first half here, and we see this B transpose. It's the same thing but negative numbers. Why did that happen? Okay, so the second part is a bit easier. What is this? Just that part on the right. This is an identity matrix here. This is an I here. And any matrix times identity matrix equals that same matrix back, so it won't change. So this part on the right here is just our B transpose again. And then this part on the left here, what does this look like? Right, it's like the identity matrix sort of times -1. So all that we'll do is just multiply everything inside the matrix by -1. So we see that here. So if you didn't see that pattern, that's fine. You just do the regular matrix multiplication steps, you'll get the right results. But this is just a shortcut that we can see. So especially if we have kind of like an identity matrix thing like this inside, or even if we just have one row like this, we got a 1 and a 0, then okay, it's just going to basically copy that column from the original thing. So shortcuts like this we can find to work a little faster. It's always nice if we are doing matrix multiplication and we have 1s and 0s, because we can just kind of skip a bunch of parts. It'll go faster. Again, if you didn't notice those patterns, that's fine. You'll still get the right results. How much time do we have? Okay. Questions? No. All right. So those are the questions I had. We have another 20 minutes or so. Does anyone have midterm questions from the sample midterm or something they want to review? No? You just want to go study for your other classes? Or sleep? No, if you're coming in person, like I will print off the exams and you can just write on the exam paper. Yeah, you don't need to bring paper. The online people need to prepare their own paper because I can't give them paper, obviously. Uh, 16. Okay, if nobody has questions, then I think we can just wrap up here. It's fine if we finish a bit early. If you do have questions, just stay and hang around and ask me, and we'll talk about whatever stuff. But that is all the matrix stuff I had for today. Okay. There are more of these practice questions in the textbook if you want to do more of them, if you feel you need more practice. That's on our classroom page and everything. So just the same sections as these ones, but like question 32 or 34 or whatever. Let's find the other parts there. Okay, we're finished. Thank you for coming, everyone. Good luck on the midterm. I'll see you all on Monday evening.